we've got Ian Pritchett here today, who's going to talk about climate positive housing. And Ian is CEO of Greencore Construction, and they are building better than carbon zero houses in Southmoor. So Ian's going to speak for maybe up to half an hour and then take some questions. Is that all right, Ian?
Perfect, yes.
Okay, would you like to make a start?
Thank you very much.
Thank you very much for coming in, and welcome to everybody here.
Thank you very much for inviting me. I'm going to start by sharing the screen so that hopefully everybody can see what's going on. Okay, so can everybody see that? Can you give me a wave if you can see the screen? Great.
Yeah.
Okay, thank you. Well, I was going to talk to you about the sort of journey that we've been on in terms of developing and learning how to build zero carbon houses. I thought I'd start with giving you a little bit of background. So first of all, I did a degree in physics at Durham University in the early 1980s, and I worked on building sites during the university holidays. And I thought building was far more fun than physics. So instead of becoming a physicist, I became a builder. I really didn't have any formal training or really know what I was doing. But the scary thing is most builders don't really know what they're doing either. So it didn't take that long to learn enough to be on a par with other builders. And I was really fortunate that by the late 1980s, early 1990s, the company was able to specialize exclusively in repairing historic buildings. And so here are some of the buildings around the sort of local region that I was involved in repairing. And that was in the period between 1987 and 2007. I sold the company in 2007 so that I could focus on eco buildings, but I'll come to that as we go along. One of the things we did specialize in was windmills and water mills, and that's really where I started to realize that our climate was changing, because when you're working on repairing water mills, you can't do that in flood conditions, and we were seeing more and more flood conditions affecting the work that we were doing. And even on windmills, it's difficult to work on windmills when the wind is strong. And in extreme cases, things like this happen. This was a windmill that we used to look after that blew over in a freak storm in 2002. And so working on windmills and water mills and having to study the weather, it became very obvious that we were seeing more and more extreme weather happening more frequently. And it's actually, as you probably know, it's quite subtle, because the differences in freak events are not that great. They're generally, you know, there's always been something similar happened in the past, but it's the frequency with which we're beginning to see these freak events happening, and also the fact that we're breaking records on a more and more frequent basis now. So by the early 2000s, I was beginning to think about climate change and the impact of what we were doing and what particularly building was having on the climate. And around the same sort of time, because we worked on old buildings and we used things like lime mortar and lime plaster, we were asked to get involved in what we thought of as the time as slightly odd projects. This was a straw bale building in Wales, and I think it was the very first straw bale house to be built in the UK. This was about 1995, 96. And we got involved in rendering the outside of it. And the scary thing is that in the 25 years or so since we did this, globally, we have emitted more CO2 than we did in all the previous centuries leading up to this. So this is a bit of a landmark project in many ways, that we've emitted more CO2 since we did it than we did beforehand. But also this was one of my early introductions to using natural materials and getting immersed in eco buildings. And seeing that and the climate change that we were experiencing working on mills led me to believe that some of the things that we used in the historic building sector had a role in new buildings. And so one of the very first projects we got involved with were, well, first of all, we set up a company called Lime Technology in 2002, which was to bring lime mortars, plasters and renders into the new build sector. And the reason for doing that is mainly that lime mortar is strong enough to stick bricks together, but it's weak enough that you can get the bricks apart at the end of the building's life. So if you build with cement mortar, really that brick only has one life, and that can be as short as 30 years in a modern building. Whereas if you build with lime mortar, you can get the bricks apart and you can use those bricks again and again, and a brick might have a life of a few thousand years. It could be used many times. And so we developed a way of using lime mortar ready mixed in silos for large scale projects. One of the first projects we won was the top left one here, which was the rebuilding and redevelopment of St Pancras Station for the Channel Tunnel Rail Link terminal, and then various other schools and university buildings. And over a period of time, we probably did 1,000 quite significant buildings out of lime mortar, and architects were beginning to use it again and again. And so we started looking at other ways that we could use lime to facilitate low carbon buildings. And there was an architect in Suffolk who was doing work with lime and hemp. So we started collaborating with him and doing some research with Bath University, and building buildings and houses out of lime and hemp. And these were some of the early buildings that we did out of lime and hemp, or hempcrete as it's often known. And one on the left here is some affordable housing for the Joseph Rowntree Foundation. And the one on the right is a project, affordable housing in Suffolk, that was designed by an architect's practice called Mikhail Riches, and you may have heard of them because they won the Sterling Prize quite recently for their affordable housing scheme in Norwich. And over a period of time, we built quite a few hundred houses of various different shapes and sizes, and we were really involved in supplying the materials and the technical supports to people. Some of these houses were very traditional looking, some of them were very modern looking. And we also did quite a few non-domestic buildings. The one on the left here is the Heritage Skills Centre at Lincoln Castle, and the one on the right is at the Centre for Alternative Technology in Machynlleth, and it's the WISE building, which is the Welsh Institute, or the Wales Institute of Sustainable Education. So it's a sort of mini university complex. And then in 2013, I left Lime Technology to set up Greencore Construction, and that really meant we had the opportunity to start to not just supply materials and technical guidance, but to actually get involved in building whole houses and building whole developments from scratch. And so since we set up Greencore, we've built about 60 houses, and some of you will have seen the project at Springfield Meadows, which is 25 houses, which we think at the moment is the greenest residential scheme in the country, although we'd like other people to exceed it and prove us wrong relatively soon. And all of this really links back to the fact that we're looking for ways that we can help reduce the carbon impact on building, and therefore mitigate the worst effects of climate change. So the Paris COP conference agreed this target of keeping maximum temperature rise below 2 degrees and preferably 1.5 degrees. And we know that the IPCC reports tell us that if we're going to stand a chance of keeping within the 1.5 degree rise, we've got to be halving our CO2 emissions by 2030. And we're already at about a 1 degree rise, and we're beginning to see the consequences in more and more of those extreme weather events I was talking about. We've seen temperatures increasing. The hottest day recorded in England, this only last couple of weeks ago, we saw the hottest New Year's Eve and the hottest New Year's Day on record, didn't we? We've seen wildfires in Australia and the west coast of America. We've seen flash floods all over the world. And really, I think all of this is summed up by this great quote from David Attenborough that what we do in the next 10 years will profoundly impact the next few thousand. So we've got to be at least halving our CO2 emissions in the next 10 years. And if we don't, it will have a profound impact on what happens for the next few thousand years. So at Greencore, our mission is really to scale up the delivery of low carbon homes until they can no longer be ignored by the mainstream house builders. So as a relatively small company, we know we're not going to build everything ourselves. We are possibly not going to be able to change the world by ourselves, but we can try and create exemplar projects that if we get enough of them out there and they can't be ignored, then they will be a catalyst for change within the industry. And that's really what we see as our mission. If we look at this within the political agenda as well as the environmental agenda, here in Oxfordshire, I think we've got some of the best momentum in terms of climate change anywhere in the country. All the local authorities in Oxfordshire have declared a climate emergency. We've got an initiative that you may be familiar with, which is a partnership between the local authorities in Oxfordshire and bioregional to make Oxfordshire the first one planet county in the world. And we've also got an initiative driven by the Oxford Group of Friends of the Earth, which is called the Oxfordshire Zero Carbon Homes Initiative. So there's quite a lot happening in Oxfordshire, and ultimately we would like to see Oxfordshire become an innovation zone for zero carbon housing. And then on a wider scale within the UK, we've got the Climate Change Act, which leads us to achieving a 100% reduction in CO2 by 2050. We've got the 6th carbon budget that was published by the Climate Change Committee, which gives us a roadmap to deliver that 100% reduction. We've got the Green Recovery Plan to get us out of COVID, and the government's fairly recent target of achieving a 78% reduction in CO2 emissions by 2035. On the surface of it, all of this looks really good and really encouraging, but I think the plans lack any detail as to how this is really going to be achieved. And that's, as we all know, the devil is in the detail, and the detail is not really there yet. If you go to the website of the Tyndall Centre for Climate Change Research, you can see the climate change budgets and the carbon budgets produced by the Climate Change Committee broken down local authority by local authority. And if we look at the 5 local authorities in Oxfordshire, we have, across the whole of Oxfordshire, a carbon budget of 26.3 million tonnes of allowable emissions. Now, technically, that is from now until the year 2100. But if we're going to be zero carbon by 2050, you could say this is our budget from now till 2050, or another way of looking at it, actually, this is our budget from now until eternity. We cannot afford to emit more than 26.3 million tonnes of CO2 emissions across Oxfordshire. So that covers not just construction, housing, it covers transport, industry, farming, all different aspects of society. Now, we think that the elephant in the room is this thing called embodied carbon, which I'll explain about as we go along. So embodied carbon, according to the Architects Climate Action Network, is responsible for about 10% of all the UK's CO2 emissions. So that's the carbon footprint that comes from manufacturing all of the construction materials, transporting them, and assembling them on site into buildings and infrastructure. So 10% of the UK's CO2 emissions come from embodied carbon. And despite this, there's no national requirement to measure it, report it, or reduce it. So this all goes below the radar, which is why I refer to it as the elephant in the room. If we think about it in terms of an average new house, and when I'm talking about an average new house, I'm talking about a house that is 100 square meters of gross internal area. And the reason I've picked that figure is it's a nice round figure, and it is pretty close to the UK average house size. So all of the emissions from the production, transport and assembly of materials on site to building a house, the average new house is responsible for somewhere in the region of 50 to 60 tons of CO2 emissions or CO2 equivalent emissions at the construction stage. And that's what's known as its carbon footprint. And then an average new house in use with an average family in it will emit about 5 tons of CO2 a year in use. So that means a new house that we build today, by the time we get to 2050, will have emitted about 200 tons of CO2. So in an environment where we're heading to zero carbon for 2050, it seems wrong to me that we've still got houses that are being built that are contributing to the problem. We need houses that at best are not contributing to the problem. At worst, not contributing to the problem, at best are actually helping to reduce that problem. So this 200 ton figure per house, if you just bear that in mind. Embodied carbon is one of those things that is not really well measured or reported, as we said. So different people that are reporting on it have wildly different figures. If you go to Taylor Wimpey's 2020 sustainability review, they don't actually measure the embodied carbon. What they do report on is this line here, which is emissions per 100 square meter completed house based on scope 1, 2 and 3 emissions, which, although not absolutely identical to embodied carbon, is incredibly similar. And they come up with a figure down in this bottom corner of 209.8 tons. That's purely at the construction stage. So Taylor Wimpey's figures appear to be much higher than the average figures I've reported on. If you go to this table here, which is from the RIBA 2030 Climate Challenge targets, they talk about embodied carbon in the business as usual category of being 1,200 kilos per square meter. So you've got some wildly different figures. According to industry estimates that we use, it's 50 to 60 tons per average house. The RIBA business as usual figures are 120 tons, and Taylor Wimpey's figure is 210 tons. So we clearly need a lot more work in consistent measurement and reporting against embodied carbon, because it's so important. Back to David Attenborough's quote, what we do in the next 10 years will profoundly impact the next few thousand. Well, there are pretty close to 100,000 new houses planned for Oxfordshire in the next 10 years. And if the figures that I was talking about of 200 tons per house in construction and operation over the next 30 years are correct, we will squander 80% of Oxfordshire's carbon budget just on building unsustainable houses. And worse than that, those houses will probably need to be upgraded in the relatively near future. If Taylor Wimpey's figures are right, then we will actually use 100% of Oxfordshire's carbon budget by about 2029. And remember, that budget isn't just for construction, that's for all sectors, industry, agriculture, transport, and everything as well. So clearly we have got a big problem. We cannot carry on as business as usual. We also have a problem with the way people think about zero carbon. When most people are talking about zero carbon, things like building regulations, politicians, what they're referring to is the operational emissions, the emissions that come from the heating, the hot water, the lighting, and the way people live in houses. They're not talking about the embodied carbon. And we really need to tackle both of these things, the embodied carbon as well as the operational emissions. So there are two main ways that we can tackle the embodied carbon in buildings. We either need to be using renewable energy or green energy, things like green hydrogen or renewable electricity for the production and transport of those materials, or we need to be using bio-based materials that have grown, and as they've grown, they have captured CO2 from the atmosphere. So we'll talk a little bit more about that in a second. We use not just timber, but we also use hemp. And I think a lot of people, when they think about hemp, they probably associated it with its cousin, which is marijuana, and think about hippies and drugs and that sort of thing. But actually hemp is a serious industrial crop that's grown on a large scale across Europe and goes into a wide variety of different industries. The automotive industry has been using hemp in its interiors for nearly 20 years now, and particularly BMW has been using hemp in all of its 3 Series and 5 Series interior doors and dashboards and roof linings and things. Back in 2008, Lotus built an experimental concept car where the whole body shell was built out of hemp. All the interior, the exterior body panels, all of the seats was entirely hemp. And it all sounds a bit wacky and groundbreaking, but actually Henry Ford was doing this in the 1940s. Henry Ford was a great advocate of hemp, and if the Americans hadn't banned the growing of hemp under some misguided association with marijuana, we would probably see the whole automotive industry building everything out of hemp by now. So hemp is not an odd material. It's a very serious industrial material that is grown. And the reason we are looking to use bio-based materials is that as they grow, they absorb carbon dioxide, and through photosynthesis, they turn that carbon dioxide into cellulose. So the carbon becomes locked up in the cellulose, the oxygen goes back to the atmosphere, and that's how we're all able to breathe, because plants are continually recycling carbon dioxide into oxygen. And if you go through the maths and the chemistry of this, it actually takes 1.8 kilograms of CO2 to make 1 kilogram of cellulose. So every kilogram of a bio-based material we can use in a house, we are locking up more than 1 kilogram of CO2. So the more bio-based materials we can incorporate in buildings, the more carbon we can lock up. And if we do a carbon footprinting exercise, measuring the embodied carbon, there is now some quite detailed guidance produced by the RICS, the Royal Institution of Chartered Surveyors. And what they say is to be able to include the benefits of carbon sequestration, that locked up carbon, you have to make sure that it is coming from sustainably sourced material. So if that's timber, it has to be FSC or PEFC certified. So those are sustainable forestry certifications. And you have to make sure that any trees that are felled are substituted with a minimum number of the same trees. And we also have to consider what happens to that bio-based material at the end of the life of the building. Is it allowed to rot? And in which case the CO2 is released back into the atmosphere. Is it burnt to release the CO2 back into the atmosphere? So there are a number of things we need to be thinking about here. So if you look at the little graph on the left-hand side, this is the cycle of carbon sequestration. So it's a plant or a tree beginning to grow, and it captures and locks up carbon up until the point that it is cut down or harvested, at which point that carbon then gets locked up, but there's some processing involved. So although we've locked up 1.8 kilos of CO2 at this point, we've got some energy used in maybe sawing, planing, processing, drying. So the amount that's actually locked up in the end product is going to be somewhere around 1.3 to 1.6 kilos of CO2 for each kilo of timber. And then that becomes locked up for the life of the building. And then we reach a point where it can either stay locked up for a longer period of time, or it can be released back to the atmosphere. So if we look at that in terms of a building, there is a certain amount of energy and carbon released in the construction of the building. And then as the trees and hemp and things that we have harvested are replanted and grow and absorb more carbon dioxide and lock it up, we get to a point where they lock up as much CO2 as was emitted at the construction stage, and then ultimately they lock up more CO2. And then the building stays in that state for its life, and then it comes to the end of its life where maybe that CO2 is released back to the atmosphere again. So if we think, what can we do to improve on this? Well, the first thing we can do is to minimize the amount of energy that's used in the construction process. So this part of the graph is as low as possible. We can then maximize the amount of bio-based material, so the sequestration comes down here to as low a point as possible. If we use things like hemp, it only takes a year to regenerate itself. Things like bamboo might be 2 to 5 years to regenerate itself, whereas timber might be 10, 20, 30 years to regenerate itself. Then ultimately, we need to make sure that the timber components that we put in buildings don't release the CO2 back to the atmosphere at the end of life. Those components are either able to be reused in future buildings, or if they are burnt, they're burnt in some sort of process that generates energy and captures that CO2. So the buildings that we're building at the moment should have a life well in excess of 100 years. And we believe that in 100 years' time, people will be smart enough about carbon that they won't just be knocking down buildings and burning them. They'll be reusing those materials wisely, or burning them in a process that captures the energy and the CO2. So if we look at what this means in terms of embodied carbon, we've recently had an external consultancy practice called WSP do some embodied carbon work for us on a typical house. And what they found was that in the construction stage, we were emitting 360 kilograms of CO2, but we were managing to sequester 700 kilos of CO2 for each square meter of floor area. So the net figure at the construction stage was minus 340 kilograms of CO2. So there's an organization called LETI, the London Energy Transition Initiative, and they have a target of getting new houses to minus 100 by 2050. We're already managing to be minus 340. So we know it can be done. And then if we look at that across the whole life of the building, which includes maintenance and ultimate demolition and some of that carbon getting back into the atmosphere, we're at a figure of minus 278 across the whole life of the building. And we believe that everybody should be measuring and reporting on this so that we can all see how we benchmark against each other and encourage each other to be going further. So our philosophy is that we should be planting more and more trees for a number of reasons. We should be planting trees to combat deforestation, improve wildlife and biodiversity, but we should also be planting trees as natural carbon capture and storage mechanisms that can then feed into industries like construction. And there was a university research project in Switzerland that calculated that if we planted 1 trillion trees worldwide, we could capture enough CO2 to reverse climate change. So there is a project underway worldwide to plant 1 trillion trees, and it's a huge number. But if you look on the right, this is a clip from a news organization reporting that in Ethiopia, they planted 360 million trees in a single day. So if we were all doing that sort of thing on a regular basis, we could really eat into this figure of 1 trillion trees. And there is enough land available to plant 1 trillion trees globally without encroaching on construction land, farming land, or industrial land. We have enough land available to do that. And then if we're planting trees and hemp and flax and other bio products that can go into our industrial economy, we're going to change our economy away from a fossil fuel based economy to a bio-based economy. And this is an article on the left here from the New Scientist a couple of years ago, where they were announcing that we were moving into the age of wood, where we'd be able to build skyscrapers, cars, planes, batteries, and even lasers from wood. On the right here is a wooden skyscraper planned for the city of Chicago. And here are some examples of engineered mass timber buildings, one in Brisbane, the world's tallest wooden office building to open in Brisbane, and one in South London. unfortunately, the agenda of building medium-rise buildings in timber has taken a setback as a result of the fire at Grenfell. There has been a bit of a knee-jerk reaction against anything flammable in high-rise buildings, but the reality is timber is not a fire risk in high-rise buildings because it's very difficult to set this sort of dense engineered mass timber alight, and even if it does catch light, it burns in a very predictable way that can be planned as part of the design strategy. At Greencore, we've been building timber houses and houses out of timber and hemp and wood fibre and other natural materials for the whole time since we were set up in 2013. And these houses can take any sort of shape and form. These are examples of houses that we've built. This one's in a conservation area between two listed buildings. These are affordable houses that we built for Sovereign Housing Association. And so in very simple terms, it is possible to get to zero carbon. The more bio-based materials we incorporate into the buildings, the more carbon we lock up. So when we design a building, we have a series of choices to make. And those choices are not just about the aesthetics. They impact what the house looks like, how it performs thermally, but also what its carbon footprint is. So if we make the right choices, we can build houses that have zero carbon footprint and are thermally very efficient as well to have zero emissions in use. And this is really what we've been trying to do. And our latest project at Springfield Meadows set the target of having zero embodied carbon and generating as much energy on each house through the PV panels as the house uses in order to be net zero energy across the year as well. So this is part of phase one. There's 25 houses in total. And phase one was our target to have zero embodied carbon. But actually, during the process of doing this, we realized that if we know how to get to zero, we actually know how to get to better than zero. You just do more of the same and lock up more carbon. So the second phase is what we refer to as climate positive, where we are locking up more carbon than we're emitting. And so in general, across the scheme, these houses have zero carbon footprint or better. They're built in accordance with the Passive House thermal performance standards so that they need minimum heating. And the other thing to bear in mind is Passive House is not just an energy standard, it's about comfort and health as well. So these are very comfortable, healthy buildings. We have calculated the amount of energy the houses should use and put enough solar PV panels on the roof to generate at least that amount of energy each year. So they should be net zero energy in use. They should also have low energy bills, but we do need to bear in mind that they are generating a surplus in the summer and exporting that to the grid, and they're buying electricity in the winter, and electricity prices are going up at the moment. So bills are not as low as they might have been at one point. The project also has an electric car club and a car sharing scheme. So the idea is to encourage residents not to have private cars or not to have as many private cars because they have access to a shared pool of 2 electric cars. And statistically, one shared car can take 8 to 10 private cars off the road. The project also has a partnership with the Berks, Bucks and Oxen Wildlife Trust, who have been involved in helping us with all of the design of the public open spaces and the landscaping to make them nature and wildlife friendly. And they're going to monitor how that performs for the next 5 years and report back to us and the residents. And all of this has been done working with Bioregional within their One Planet Living framework, and the project's been awarded global leadership status. It's also the first private residential scheme to be funded by Triodos Bank. Triodos, as some of you will probably know, is probably the only sustainable bank in the world. And they funded affordable housing and renewable energy and things for many years, but they've only recently started to fund private housing, and they insist on it being built to the very highest environmental standards. So in summary, the secret formula we use is bio-based materials to lock up the carbon, the passive house performance standards, so very high levels of insulation, designing out thermal bridges, making the buildings very airtight, having triple glazed timber windows and a ventilation system that's got heat recovery built into it, so that we're not losing all the warm air when we remove the stale air from the building, because it's being used to heat the fresh air coming in. And then the houses don't have any fossil fuels, so everything is electric, the heating, the hot water, the cooking, and then they've got PV panels to generate that energy. And in a number of the houses, they've also got batteries to store that energy. A lot of people, or a lot of mainstream construction companies and house builders say that it is not viable to build zero carbon houses because they say it's too expensive. So we've looked into what the value chain is. When you buy a new house, how much of that is actually from the construction and how much is from all the other bits. And it turns out that somewhere between 40 and 45% of the cost of a new house is actually its construction cost. There's a lot of people skimming off bits, whether it's the landowner making money by getting planning consent, or the local authority charging Section 106 fees, or the profit, or the finance. So there are lots of other places that we can squeeze money out of the system. So we don't actually think it costs more to build zero carbon houses. You just have to look at things differently. But even if it did cost a little bit more, there are other ways to mitigate that cost in order to look at the whole life cost of the building. During 2019, you were probably all aware that there were the school strikes going on, and I'm not a political type of person, but I found myself getting involved and marching through Oxford with a banner calling for zero carbon homes now. And I think the world's really started to wake up to environmental issues, and the arguments and the agenda changed. And this was the time when we realized that if we knew how to get to zero carbon, we knew how to get to better than zero carbon. And I went to a number of talks by people, and Councillor Tom Hayes in Oxford used this phrase a couple of times at talks I went to: do the best you can until you know better, then when you know better, do better. And I think it's fair to say something like this has really inspired us, because we realize that as we learn from houses that we build, we get more knowledge and we know how to do better, and therefore we need to be doing better. And this is why we've launched an initiative to build at least 500 climate positive houses in Oxfordshire by 2025. And when we say climate positive, we're talking about houses that lock up more carbon than they emit, they generate more energy than they use, they increase the wildlife and the biodiversity on the land that they're building on, and they become a catalyst for local food production, green transport initiatives, and we're also looking to work with local community energy schemes where possible to make neighbouring villages zero energy. So the idea is that instead of trying to minimise the negative impact on the environment every time we build something, it's working out how we can create a positive impact on the environment when we build something. And it's about trying to go beyond zero so that we can start to rebalance the emissions from other people's activities. And we're also looking for an opportunity to build a green business park in Oxfordshire so that we can attract other like-minded eco-businesses, make Oxfordshire an innovation zone for zero carbon housing, zero carbon building, and lots of other things will follow on from that as well. So I think it was Abraham Lincoln that said that the best way to predict the future is to create it, and that's really our job at Greencore. So thank you very much for patiently sitting through all of that. I hope that didn't go on too long. I'm going to stop sharing so that we can start to take some questions.
Right, Ian, thank you very much for that talk. Very, very interesting.
Thanks, Karen.
Right, let's have a look at, is anybody ready to ask a question? You can either put your hand up and we'll attempt to spot you, or put up a virtual hand. Roz, you've got a virtual hand up. Would you like to ask?
Yeah, hi. Thank you very much, Ian. That was really interesting. But I was a little bit confused whether you were really promoting wooden houses or hemp houses. And you mentioned bamboo very briefly, but you didn't really talk about that. Where does that sort of fit in?
Right. Okay. So at the moment, structurally, we're using timber. So the main structure is timber. The insulation is a combination of hemp and wood fibre. And things like bamboo lend themselves to particular fittings, so things like flooring, kitchen units, and maybe doors in due course. At the moment, there's a relatively limited range of things that you can get made out of bamboo, and obviously bamboo doesn't grow in this country, so you have to look at the sort of whole chain of custody and environmental impact. But I think we'll see more and more bamboo products come forward, and we'll be looking to see where we can incorporate them further, because they have a shorter rotation of carbon within them than timber. But we're also looking at how we can use UK grown timber. Timber in the UK grows faster and therefore is not as strong as timber that's imported. We've been importing timber from the Baltic into this country for the last 700 or 800 years. So we don't really have a very well established UK timber industry. It's all about importation. So there's a bit of catching up to do in terms of using UK timber. But in essence, we're talking about the structure being timber, some external finishes being timber, and insulation being hemp, and wood fibre, which is made from waste timber.
Okay, thank you. Is hemp grown in the UK?
It is, yes. Yeah, we source ours from the Yorkshire-Lincolnshire border.
Cool, thank you.
Okay, right. Bud, is your name Bud? Bud Tillinghast.
That's right. You've got it right.
Hi, Bud.
Hi there. Ian, with your innovative mind, I wonder if you've run into co-housing?
Yes. Yes.
Because that changes the sort of standard of buildings and increases the use and cuts down on the number of square meters needed per person. For instance, a co-housing unit will have a couple of visitor bedrooms, meaning nobody else has to have an additional bedroom in their house. So I'm wondering what you've run into on that.
Yes, I'm aware of a number of co-housing schemes, and we have discussions going with a couple of co-housing groups at the moment, because I think it's a great way to complement the type of construction we're talking about. Very often we're still building houses that are far bigger than they're needed, and they've got 3 spare bedrooms. So the idea of being able to have 1 or 2 houses on a scheme that are available for guests, rather than everybody having to have their own spare bedrooms, just makes so much sense, doesn't it?
It does, yes.
Okay, we've got, oh, David, you're waving.
Hello there, yes, it's David here. Yeah, I'm not so good on the Zoom, I'm afraid. Am I communicating okay?
Yes, I can see it.
Well, a couple of observations, sort of thing. The first is the guy who does the Just Have a Think.
Yes.
Videos and things, which are really very interesting, very well researched. They're getting carbon negative steel manufacture, which I find bizarre, but anyway, and carbon negative concrete production. So they're able to manufacture concrete which absorbs carbon as part of its, because both of those things are hideous normally for carbon. And so I wondered if you were across that. And furthermore, I live in an old wimpy home.
Right.
I've done a lot too, but have you been involved in any existing property renovations. You've got any good ideas in that area?
Right. Well, if I start with the steel and concrete first, the concrete that we use has 50 to 70% of the cement replaced with blast furnace slag, which is a waste product. And we are looking to move to 100% replacement of the cement with blast furnace slag. So I think that gets to about a 90% reduction in the carbon impact. I'm not at the moment aware of carbon negative concrete, but I'd be really interested to see and hear more about that. And I'm not aware of the carbon negative steel, but obviously, as you say, steel production is hideous, and we do need to find ways to reduce that. So there are lots of initiatives going on, and the more we can bring all of these to the forefront and incorporate them in the things that we're already doing, the better. In terms of upgrading and retrofitting existing houses, I have been involved in quite a few over the years, but I'm not involved in any at the moment. And one of the reasons is that it's very difficult to do everything well and at the same time. And so we have decided that we have to focus our attention on the new building side and really crack that 100%. And I think some of the skills that will come out of that will then feed into the retrofit sector. But retrofit is significantly harder than building new buildings. You know, I freely admit that by building new buildings, we've taken the easy option. It's the low-hanging fruit, if you like, to try and crack that first before sorting out the retrofit side.
Okay, nice.
There are some good initiatives around. So I don't know whether you're familiar with the Cozy Homes initiative. There's some really good advice and support available for retrofit through the Cozy Homes programme in Oxfordshire.
Well, I wasn't so much aware of that one, but you know, I've researched Passive House. There's a renovation standard, which obviously isn't as good as Passive House, but it's like
Enefit.
It's the what? Sorry,
called Enefit.
That's it. Yes. Yes.
Yeah. It's a very, very good and really rigorous, robust standard. It is quite challenging, but it's worth looking at.
You happy with that, David?
Yes, thank you very much for your response there.
Thanks, David.
Okay, I can see 3 more people with their hands up. We'll start with Councillor Andy Crawford.
Thanks, Caroline, and thank you, Ian. I've had the good luck of visiting the site at Southmore and being given a tour, and I was absolutely fascinated. So thank you for that.
Thank you.
You've got an ambition to deliver 500 houses over the next number of years. And I wish you the best of luck. The typical landowner who has planning permission to build houses will sell it off to the highest bidder. And I guess I'm wondering the extent to authorities, one of which I represent, can, although they also have a duty criteria as well, how you would see it working to get perhaps land that a local authority owns and wants to develop to build your houses, personal home type house. What sort of interreactions and cooperation is best had to help you deliver your ambitions?
Yes, your line broke up a little bit there, but I think I got the gist of it. So what can we do and what can local authorities do to try and encourage this sort of thing? So I think that the first thing is there is fortunately an increasing number of landowners who are looking to do something a little bit different and don't want to sell their land to a volume house builder. They want to do something worthwhile. So I'm glad to say we're working with a number of people like that. I think local authorities, obviously, if they're selling land, do have some sort of duty to get the best price for it, but they also, I think, increasingly have a duty to do the right thing in terms of the environment as well, and in terms of doing something that is going to support policy. And for a local authority that has declared a climate emergency to be able to facilitate exemplar zero carbon projects supports the commitment to the climate emergency. But I think you can actually find ways to do both, to get best value and also do the right thing in terms of zero carbon development. So I'm not quite sure whether we've lost Andy, have we? He disappeared off my screen anyway. So the sort of things that can be done, I think, are using the planning system to level up the playing field, so that if planning consent was linked to doing higher and higher standards of building, one simple question: why are we giving planning permission to build anything other than zero carbon housing in a climate emergency? There seems to be a tension at national government between delivering the numbers of houses that government has committed to and being able to deliver the quality of houses that we need, and numbers always seem to take priority over quality. And by quality, I also mean, energy performance standards. So that's one thing that the local authority can do, really start to toughen up on planning, bring in supplementary planning guidance. Friends of the Earth launched a supplementary planning guidance document which went to all the local authorities in Oxfordshire in July 2020 with a plea to adopt it, because if they adopt that sort of supplementary guidance, it gives them some teeth in legislation. I think local authorities can also start to look at whether the CIL, the Community Infrastructure Levy, which is a levy on developers building new houses, can that be a variable tariff? We know that if you drive a car, if you drive an electric car, you don't pay road tax. If you drive a gas guzzling V8, you pay a lot of road tax. We could have a variable tariff in terms of CIL, where zero carbon housing had little or no CIL, and the remainder of conventional housing paid a premium, so that the receipts to the Treasury were still the same, but there was an encouragement to do the right thing and a disincentive to do the wrong thing. I've had discussions with national government about using stamp duty as a similar tool. That stamp duty at the moment is linked to the cost of a house rather than its energy performance. We could easily, for new houses, link stamp duty to energy performance. We are seeing changes to building regulations that will start to push us towards better quality and more energy efficient housing. But I think there's a whole raft of things that we can do. And certainly for somebody like me, I'm always looking for the sweet spot where you can do all of these things at the same time, where you can give a landowner a really good return for their land and you can develop really good energy efficient housing at the same time. So I think it's possible. It's not easy, and if it was easy, everybody would be doing it, but it is possible to find these overlaps. Does that answer that one for you?
I think Bud's muted.
I think that was Councillor Crawford.
Oh, it's that's it. It was Councillor Andy Crawford who's muted. Right, well, thanks for that answer, Ian. Helen Johnson has her hand up now.
Thank you, and thanks for the talk, Ian. I just have a question coming really from a more sort of personal viewpoint on it, and what I can do to my home really to try and make it more carbon neutral. And so thinking about the sort of retrofit aspect, and I was wondering how widespread you thought this kind of ability to make houses carbon neutral was in amongst tradespeople. If I wanted to do something, if I wanted to do an extension, where would I go? Do I have to go to Greencore or other companies? And actually, you kind of touched on this already, but do you think that the local council planning department already looks more favourably on proposals that are carbon neutral?
Right, so there's a couple of things in there. The easy one, I think, is do the planning authority look on carbon neutral schemes more favourably? The surprising answer is no. I think it's actually the opposite. It's more difficult in planning terms to do something zero carbon than it is to do something that is conventional, because the current planning system is was set up quite a few years ago and is really set up to rubber stamp business as usual. It's not set up to look at carbon and energy. In terms of your own house, there aren't enough tradesmen. There are very few tradesmen who understand energy efficiency. So I mentioned the Cozy Home scheme.
Yeah,
that's quite a good one as a starting point to look at things like upgrading windows, loft insulation, draft proofing, ventilation, those sorts of things. But I think we've got to get these tradespeople through the local colleges. So there are a couple of local colleges that we were engaging with pre-COVID, but we need to sort of rekindle that relationship post-COVID. They're beginning to put courses in place for training the tradesmen of the future for things like retrofit, installing heat pumps, insulation, air tightness, and all of those sorts of things. But honestly, it's going to take quite a few years to get to the pool of tradespeople that we need who really know what they're doing.
Yeah, okay. Okay, we'll put it off for a few years then.
No, don't put it off. Be one of the pioneers that helps generate those people through.
Okay, thank you.
Thanks.
Right, do we have any more questions? I can't see any more virtual hands up. Oh, hang on, Dan the Plan.
You've got two on the second screen, Caroline.
Okay.
Hi, Ian. Great talk. Question about the batteries. Is it a collective battery, or they have individual power walls? And how does it work over 12 months? They're storing during the summer, and then they're using as much as they possibly can during the winter, and when they run out, they go back to the grid. Is that how it works? Right.
The batteries at the moment are individual house batteries. They're not the Tesla Powerwall. Tesla Powerwall is an AC battery, and the local district network operator won't let us install AC batteries, so we have to have DC batteries which work the other side of the inverter. So basically, in the summer, when the sun's shining, the solar panels generate energy, and as much of that is used within the house as possible. If there's a surplus more than the house is using, it then charges the battery, and then when you get to the point the battery is charged and the house can't use anymore, it's exported to the grid. And then at the times the sun is not shining, the electricity is imported from the grid. So the grid acts, if you like, as a big buffer, a big battery, because you're exporting the surplus to the grid and importing it when you need it. But we've learned an awful lot through the process of doing this. We've run into an obstacle where the SSE networks, the local network operator, won't let us export from all of the PVs on the project. And so we're exploring ways that we can overcome that. And one of those is a large scale site-based battery, which would give us a much longer duration. So you might have 200 or 300 kilowatt hour battery size in that case, maybe even half a megawatt. And all the surplus PV generation would then go into the site battery. And then overnight, if there was still any capacity in the battery, it would top itself up from the grid when electricity is plentiful and cheap. And then during the day, the whole site would then operate from the large scale battery. And that battery would also have the potential to export to the grid at the times when the grid is under strain. But all of this is quite new technology, and the grid is not ready for it yet. So we're now, Springfield Meadows is now officially part of Project Leo, Local Energy Oxfordshire, which is run by the Low Carbon Hub. And we have Jack Irwin on the call, I see. So we're working on solutions to solve our export problems at Springfield, but hopefully to sort of establish protocols that can be used for future projects and for other existing schemes as well to make that work. So there are a number of obstacles to zero carbon development. The grid is one, the planning system is another, and we need to reform all of these at the same time.
Thank you very much.
Thanks, Dan.
Right, we've got Katherine Webber with a hand up. Katherine, do you want to ask your question?
Oh yes, thank you very much. Thank you very much, Ian. I found that an absolutely fascinating talk. I haven't actually been round yet to look at your houses, but I know of people who actually have bought houses there. And actually that's what I wanted to ask is, how much does your average house there, do you have affordable housing, social housing, or is it just market price housing? A second question, I am actually on the Bale cabinet, and one of your questions was to talk about how difficult it is to persuade the planning to be more carbon, to be friendly towards zero carbon ideas. Well, I can assure you that we are absolutely pro that system. We want very much to get our houses carbon zero, but we do have a lot of obstacles that we have to overcome. But you might be interested to know that we have set up a design guide, which is at draft stage now, and it is full of ideas that we want developers to follow, which are based on carbon neutral ideas. So that will come out very soon. Another question I wanted to another point I wanted to raise is, of course, we are very much tied to building regs. And until those are sorted out by the government, that will mean once the government are much more definite about their ideas about carbon zero, then builders will have to follow much more, as you will know. So the building regs are absolutely paramount here. And the last question I wanted to ask about is looking at your design. You had solar panels, and I wondered if you'd actually thought about using roof panels instead of solar panels, because that would look more attractive, and maybe window with solar ability to capture solar. So those are the questions I'd like to just throw out to you, and thank you again.
Thank you. So the first question was about the tenures of the housing. So there's 9 affordable houses out of the 25. 6 of those are affordable rent and 3 are shared ownership. And then there's 16 open market houses. The 9 affordable ones now belong to Sovereign Housing Association, and they look after those and manage the shared ownership relationships and things. In terms of cost for the open market, they're really driven by local values in the area, really. We would like to be able to achieve a premium for a zero carbon house. I think in 1 or 2 cases we possibly have, but statistically it's very difficult to to be able to be certain about that, because there are so many sort of bigger factors going on, things like Brexit and COVID, that have skewed the market that we can't really see. But certainly pretty well everything we're building in the next 12 months will be affordable housing. We're working on projects with various local authorities and housing associations. It's good to hear that you've launched the design guide, and I think I got a link to, it's with South as well as Vale, presumably. I got a link to that either this morning or yesterday, so I must have a look at that. And I think the strange disconnect is we're very aware that the elected councillors really support zero carbon, and I think the planning offices individually support zero carbon, but the impression I get is that their hands are tied by the existing framework. So I think planning officers are the most fantastic police force, and if we could get them to police the right rules, we could probably solve the issues quite quickly. So I hope that the sort of design guide that you're talking about will give them the tools that they need to do that. And then in terms of solar panels, we did look at the solar roof tiles, and the ones that a lot of people are familiar with are the Tesla ones, which unfortunately are not yet available in the UK. There are some UK manufactured ones that we looked at, and they've got some advantages, particularly for cutting into valleys and awkward shaped roofs and things. The big problem that we had at the time was that if you buy a panel, it is guaranteed to give you 90% of its output in 25 years time, whereas a tile at the moment is only guaranteed to give you 80% of its output in 10 years time. So I think there's a little bit more progress required, and maybe it's just longevity testing on tiles before people have the confidence that they'll get 90% in 25 years. We haven't really looked at PV glass yet. We're aware of it, and we've had early discussions with manufacturers, but we haven't really had a chance to explore that.
That's great, thank you.
Thank you.
Great. I think Valerie Shaw had her hand up too. Valerie?
Yes, I did, although Katherine Webber has actually made some of the points that I wanted to make. I too am a local district councillor, and I have had the good fortune to go around the Southmoor site, and incredibly impressive. I wish that so many of the applications that come to the Vale for, and certainly come to the planning committee, were for applications much more like the Southmoor site. Sadly, you know, so much of what we see is doing the minimum possible. Going back to something that somebody else had raised, and I don't remember her name, I live in a very old property and I love my house, but obviously it's never going to be zero carbon, but you know, when are you going to start doing something that will help people like me who don't want to move but just want to make their properties more carbon friendly?
Thank you very much for all the nice things you said about Southmoor.
It was wonderful. It's very impressive.
We probably as a company are not going to be getting into retrofit for quite some time, because we've got our hands rather full with the new building side of it. But I think the sort of house that you're talking about, I think that the salvation of that will be the greening of the electricity grid. So it will be, there's a limited amount that you'll be able to do in terms of upgrading the house. it will be about making the energy source that goes into it zero carbon, whether that's a mixture of hydrogen and biomethane and things coming through a gas network, or moving to zero carbon renewable energy through the grid. But I think that's probably your most realistic way forward, that will come from the sort of top down rather than the bottom up.
Okay.
Right. Okay. Has anybody else got their hand up? Can you see anybody, Sally? No. You're muted, Sally.
No, I can't see anyone else. And I don't think there's anything else in the chat either.
No, I think that's it. Oh, David, you're waving.
Yes, just a quick one. I mean, I think we've been around all the construction side of things. What about expansion, Ian, and you know, your own company expansion, and that is to say, taking on youngsters, and I know you mentioned colleges that you need to, you know, re-establish your links with, and that type of thing. I mean, could you somehow accredit local builders if they showed the right initiative, that type of thing?
Certainly, first of all, we are looking to expand. We certainly won't be able to deliver 500 plus houses in Oxfordshire over the next few years without expanding. So we're in the process of raising some external investment to allow us to expand, and part of that will be certainly working with colleges to bring on young people. Yes, I think we do use quite a lot of local, certainly subcontracting companies. So ground workers, plumbers, electricians, plasterers, decorators. So we do work with quite a lot of people, and we will be looking to work with an increasing number of people. So I hope, you know, certainly we've seen a number of those individual people and companies that we work with really buying into the whole concept, and it's not just that they come to work and forget about it. They do actually take it on board, which is encouraging.
That's really encouraging. And I must book my own visit to come and see your Springfield Meadows.
Well, we can set up another visit. It's no problem. It might be worth leaving it a month or two to let the weather warm up a bit. It's been pretty cold and miserable there the last few days.
Yeah.
All right, Helen, did you want to ask something else?
Sorry, very quickly. But those people that you just mentioned, the plumbers and everything that you work with, like, how do we get hold of them? Are they available to people for residential projects, or are they just for developers?
Some of them are. So some of them focus on new buildings, but some of them also do residential work as well. Okay.
But there's no kind of list, like I couldn't find some kind of list of eco-friendly tradespeople anywhere that you know of?
No. Okay. Places that you might look, there's an organisation called Oxfordshire Green Tech. You might find that there are some within that.
Okay.
The Association of Environmentally Conscious Builders.
Okay.
May well have a list.
Yeah.
The Passive House Trust has a scheme for accrediting people for retrofit, so you might find that they've got a list as well.
Okay. Thank you. I won't harp on about it anymore, but that's really helpful.
Certainly those spring to mind. Yes.
Thank you.
Thanks.
Catherine.
Yes, I'm sorry to come back to you, but just one question that hovered in my mind as at the end of our little talk was, have you considered modular housing, and would you think you could do modular housing which is based on wood, carbon zero, and would therefore it would be open the market to to the pockets of much of people who can't afford your type of house. Is this something you might consider?
So what do you mean exactly by modular housing? Because it's quite a wide definition, and different people think of it as different things.
I suppose what I'm thinking of is what I've been sent from America and Sweden and Germany, different houses that they've built, almost like flat pack houses that are sort of delivered.
Yes, so our houses are actually made in a factory as flat pack. We've, until very recently, our factory has been based at Worminghall between Wheatley and Tame. We're just in the process of moving it to Bicester. So everything is panelised. So this all comes under, there's this term called modern methods of construction, or MMC. And there are two broad types of MMC, either flat packed where everything comes to site as panels, or three-dimensional where it comes to site as sort of a big chunk of a house, and you put together 3 or 4 of them to make a whole house. We think the flat pack modular approach is the right sort of happy medium between being flexible enough to meet the needs of the planning authorities so that not every house looks the same, but creating some standardization. So I think the construction costs are not particularly dissimilar to ordinary construction costs. You know, in essence, what makes a house affordable is how much you have to pay for the land in the first place. So if land is available at little or no cost for building affordable housing, then this is definitely the way to do it.
But if I remember in your pie chart, you had construction cost, it was almost half the cost of a house.
Yes, about 40 to 45%.
Land, the little triangle for land was actually quite small, which quite surprised me.
Right, shall I just go back to that?
Have a look at that one, yeah.
So, see if it will let me.
Yes, there we are.
So the land value was the basic land value, the cost of promoting it through the planning system, and the planning gain. So the land side of it tends to be around 30%.
Oh, right.
And then if you've got things like the developer's profit can often be quite a big chunk as well. If you can get the so this is also based on a scheme that includes affordable housing and open market housing. If you were just looking at the affordable housing or just looking at the open market housing, the ratios would be different. This is blended across 35% affordable in here.
Yes, which is what we have at the Vale, yes.
Yes.
Okay. So could you see that in working out as in our flat packs? I mean, I'm thinking of figures that are way below, you know, we're talking about to 150,000 for a flat pack house, which you can get in America and you can get in Germany, but I just don't know whether you can get that here, looking at your pie chart, whether that would work.
I think it would, yes. Unfortunately, it isn't just the 150,000. There's normally costs associated with infrastructure and getting roads and drains and services to the houses as well. But certainly being able to achieve houses that are well, half the price of open market houses is very achievable.
Well, that's interesting. Yes.
I mean, when we sell a house to a housing association, in general, it's about half the cost of it would be if we were selling it on the open market. and that still just about works out viably.
Well, that's very interesting. Thank you. Yeah.
Yeah, that's okay. Thank you.
Okay, well, if that's it, we've kept you talking till 9 o'clock, Ian.
Well done. Thank you.
Obviously, lots of interest and lots of questions for you. Thanks very much for talking to us. I've really enjoyed it, and I'm sure everybody else has too. Thank you for coming, everybody. Can we show our appreciation with a clap or a virtual one, please, for Ian?